So now we're going to be looking at how to do trig integrals. And as a note, this is not typically a BC calculus exam topic, but it is a pretty common calculus 2 topic. So trig integrals are like powers of sine and cosine or other trig functions. So the trick in this case is it's always some kind of use substitution. Like if I have an odd power and odd value out, this one's easy because I can just say I can use cosine x, and du would be negative sine x dx. Okay, sine x dx. And so negative du would equal sine dx, sine x dx. And so then I have my du right here, and then this is u to the fourth. So this would be integral of u to the fourth du, which would be 1/5 u to the fifth plus c. And finally, substituting for u would be 1/5 cosine to the fifth x plus c. Okay. So again, it's the same when if I have an odd power, because what I want to do here is I want to pull out a sine x, and then I'm going to have a sine squared x and a cosine squared x dx. And I want this always in terms of cosine, because I'm going to do u equals cosine x again. So du is negative sine x dx. So I'm always going to do this sort of process. So when we do this here, I need to convert this to cosine. I'm going to use the identity that sine squared x plus cosine squared x equals 1. And so sine squared x is equal to 1 minus cosine squared x. So this integral, I have a sine x, and then I have a 1 minus cosine squared x times a cosine squared x dx. So then I can do the u substitution more easily. The sine x dx becomes a negative du, right? This part is my du here. And then all of this is going to be 1 minus u squared. And then distributing this out, this is going to be u squared minus u to the fourth du. And so then when I do, then I can do the antiderivative or power rule for each of these. This is going to be negative 1/3 u cubed plus 1/5 u to the fifth plus c. Because this negative is going to make that negative and negative make that positive. So this is negative 1/3 cosine cubed x plus 1/5 cosine to the fifth x plus c. So if you have an odd power of one of the trig functions, it's actually not too bad. So again here, odd power, I'm going to pull out a cosine x. So this is going to be the integral cosine x dx, because that's going to be like my du. And then since I pull out a cosine x, I have sine 6 to the x cosine to the fourth to the x. And so in this case, u is going to be sine x, because the du is going to be cosine x dx. Right, so this is going to be my du. Now my cosine to the fourth x, I need to convert into sine x. Well, this is cosine squared x squared, right? And then remember the cosine squared x I'm going to replace with 1 minus sine squared x, the trig identity. So then this becomes the integral of du. Sine to the sixth is just u to the sixth. And then this is going to be 1 minus u squared, quantity squared. Okay. And to do this one, the simplest thing is, I guess, just to FOIL everything out, because it's not too bad. So if I have u to the sixth, 1 minus u squared squared, I can do an expansion on this. This is going to be u to the sixth, 1 minus 2u squared plus u to the fourth. So distributing all of that, it's going to be u to the sixth minus 2u to the eighth plus u to the 10th. And so the integral of that then is going to be integral of each of these. It's going to be 1/7 u to the 7th minus 2/9 u to the 9th plus 1/10 u to the 10th plus c. And so then finally back substituting, it's going to be, these were sine to the 7th x minus 2/9 sine to the 9th x plus 1/10 sine to the 10th x plus c. Okay. Thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.